Can we define anyway zero potential? Again, the basic condition. Can we define anyway zero potential? Yes, it is. So I'll begin with this one. Let it be 0 volt. Potential at this point, let it be V1, V2, V3. I think this will be sufficient, no? If we can find out. We can easily get current to all the branches. No need to assume anything that one. So you can, some students, what they do, they assume here 200. Okay, nothing wrong. 200, here's a 0. Anyway, like we are going to write loop equation, no? That'll be covered. So no need to assume again how many possible unknown nodes are there. Means how many possible nodes, what minimum number of nodes we can assume, so that calculations will become easier. If more number of nodes are there, how many nodes are there, those many equations will come into picture. Are you getting this thing, that one? So just don't assume that one. Don't write like this. What I mean to say, V4. We know this is 0 volt. What is V4? 200 volt, no? There's no necessity to write. And here also, V5. What is the potential difference? So V5 minus V3 should be minus 120. We know that one. So there's no necessity to define this as node. So these are the possible things. In that, you can ask questions. Why you define this as 0 volt? Why can't this be 0 volt? Anything? Can you make this as 0 volt, sir? Yes, you can define anything as 0 volt. Okay, the option, the choice is yours, sir. There's nothing called like this should only teacher what is defined that is 0 volt. No, need not. Anything you can define as 0 volt. Can you assume 0 volt at two places? So it's not, no. 0 volt is defined one point. And if you by chance, if you by calculations, if you get 0 volt, okay, well and good. What do you mean by 0 volt? Points which are at same potential. So definitely what mean these are 0 volt, no? Yes, it is, because they're connected by a conducting wire. You cannot assume this as 0 volt. You'll be wrong. This one, so 0 volt should be there if two points connected by a conducting wire, and if you make any one point, so means here this I made 0 volt. Since a connecting wire is available, no, so therefore I can make this also as 0 volt. If any one resistor is there here, then you cannot make this 0 volt. Getting the basic rules, just electrostatic principles I'm applying here. These two points are connected by a conducting wire. The conductor must be equipotential. That's why I'm writing 0 and 0. Okay, then let's go for writing equation. V1 so this should be V1 V1 minus 200 minus 0. You write better 0, you'll get exact picture. Means I'm taking this branch. V1 minus 200 by 90 plus V1 minus 0 by 15. V1 plus 250 minus V2 by 30 equal to 0. Look at this. What is the path? It's like this. V1 minus 200 minus 0 by 90 ohm resistance. V1 minus 0 by 15. V1 plus 250 minus V2 by 30. So there's the equation 1. Solving, you will get relation between V1 and V2. One equation, let it be. Then next we'll write one more. I'll write down. You can focus on the solving. This for V2, the equation will be V2 minus 250 minus V1 by 30 plus V1 plus 120 minus V3 by 100. Okay, let me check it. V2 plus 120 minus V3 divided by 100. This will be V2 minus V3 by 20 equal to 0. Let's write for node equation. This is at node 1, at node 2, at node 3.
Sir, it should be V2 plus 120 minus V3 no?
V2 minus V3 by 20, no?
V2 plus 120 minus V3.
V2, okay, 2 is missing. Yeah, fine. Yeah. At node 3, it should be V3. V3 minus 0 by 21. So next again, V3 minus V2 by 20. V3 minus 120 minus V2 by 100. Even current will also flow this one. This is also a branch connected to V3. So this should be V3 plus 300 minus 0 by 60. You see that here how many drops have come? 4 drops. Here where are the 3 drops? So look at the junction here. The junction 1. Here open there are 3 branches connected to it. That's why you are having 3 IR drops. Junction 2. Junction 2. What happened there? The 3 branches are linked to it. So that's why you are having 3 IR drops. Junction 4. There are how many? 4 branches connected to it. So 4 IR drops should be there. I think we should make observation of these things also. So for a junction, how many branches are there? Those many IR drops will come into picture. All these are observations, nothing. There's no any concept, nothing. So those students who will practice few problems and different situations if they come across, no, the more skilled you'll be there, that one. So you look at the previous problem, you look at this, the number of branches that are connected to junction, that will determine number of IR drops. So this also we have to keep in mind, that one. So when we are solving problem, no, we have to just cross check once how many IR drops are there. So that will determine that how many branches are linked to that given junction. I suggest you, no sir, this is really a little bit, I'm not that good, that one. So you assume here I1, I2, I3, I4, 4 equations, like a 4 unknowns, then solve it, you'll get the required answer. Or branch current method, you assume current I, here I1, I2, and C. The distribution of current itself will take more time. Within that time open you can solve and you'll get the answer. But here also there's no way. 3 nodes are there, 3 equations we have to write. You can't write, no sir, I don't write V2, V3, I'll assume only V1, then I'll write equation. So current in these two, current in this branch will be different, no? So we can't write. I'll give the values later on. If you want to, can cross check them. V1, you have to check calculation. I did, I think with calculator, I got this much of values. So check once. V3, 0.19. What do you mean by negative sign? What you should interpret if you get negative sign? You don't do anything, just leave it here. Then if you want to find out current through any branch, what you should do, you should take help of that negative sign. Suppose, say, let's do one thing. We'll find out current through this branch. So just will start like this. Let this be, this will be I1, IA, I'll call it. How to calculate that IA? We know potential. This is 0 volt. This is V1. How to calculate the current? I'll show for one. Because there's a major idea of that one. To calculate the current in all branches. How to calculate that current? So I'll start with this one. The same current will flow here, no? Again, IA, the current in this branch. Current here will be IA. This is IA and this is IA. So don't write IA here. You'll be in a big trouble. Don't write IA here. This is the current. So what you should do, you can start from here, 0 volt. Write KVL from here, 0 plus 20 minus 90 IA minus of minus V1. Why minus of minus V1? V1 you have to substitute with negative sign. So I'll write down the loop equation now. 0 minus 0 plus 200 minus 90 IA minus of V1. Substitute V1 with sign, get expression for IA. Let this be IB. Let this be current in various branches. So now you can ask questions, sir, on what basis you are assuming current? Arbitrary, that one. If I get current negative, I'll change the direction. Is that okay? So I'll show one more. So something for this branch, I'll show it. This will be V2 minus 100 IE plus 120 minus V3 0. Substitute V2, V3 with sign, you get IE. So if they give earthing in the problem, what to do? It's good, no? Directly you are going to assume zero potential and you are going to move forward. Today I'll give a few more problems on this nodal analysis. For 5 problems I'll give it. Try to work on them. Some 2, 3 will be very big.